Hello, I'm Mark Siddall and thank you for stopping by to watch this video. Now, if Volkswagen did houses, if they made houses, what would they be like? You're no doubt aware of the Volkswagen scandal that's hit the headlines repeatedly over the last few weeks. The emissions cheating software is at the heart of the problem. We're told that the decision to fix the software won't actually change the fact that the cars themselves will still be responsible for higher emissions than they're meant to have, and they'll become less efficient because the software won't be doing quite the same things. Now, this means that car owners with fuel bills will be facing a challenge because the fuel bills will be that much higher than they should be, and they could also be subject to much higher road taxes in the future because the emissions from the cars are greater than were expected. So who's going to foot the bill? If it's not the car company, then it's going to be the consumer, and that's you and me should we have a car that's affected. In the UK, the Consumer Rights Act came into force on the 1st of October 2015, and this is the latest legislation driving forwards the rights of the consumer. And a consumer is defined as an individual acting for purposes that are wholly or mainly outside of that individual's trade, business, craft or profession. Now, why is this important? And why is an architect like me rattling on about cars and consumer rights? Well, here's the thing. There's some striking parallels to be made between this whole scandal that's hitting the headlines about cars and to do with buildings. So I'm an architect. I'm based up in the northeast of England, in the city of Durham, and yeah, I'm going to be talking you through some of the things that have been based around my experiences and some of the research that I've been doing on projects over the last 9 or 10 years. And you'll start to see that there are some striking parallels between what's going on in the car industry and what's going on in the UK construction industry as well. And I do have a suspicion that this could be actually a more pervasive issue globally. So, what we're finding is that due to failings in the design and construction processes, most houses lose more heat than they should, and they're not ventilated properly either. In many cases, these houses have, in theory, been designed to the building regulations or the now defunct Code for Sustainable Homes. But in practice, well, as you'll see, some of the performance issues that start to kick in are demonstrating that they're not actually satisfying these fundamental basics in actuality. And that has all sorts of consequences for people that live and occupy homes, specifically new homes that have been bought from house builders and the likes. So, in my view, it's a critical mistake to theorise before one has data. This is a great quote from Sir Arthur Conan Doyle, great detective Sherlock Holmes. And I think that this is kind of really key for understanding house building and construction in the UK. Now, a little bit more about me and my background. I'm an architect, as I say. I'm a passive house architect to boot, so I design ultra-low energy homes. I'm a member of Constructing Excellence in the North East, and I'm a technical advisor to the UK Passive House Trust. I'm also a trustee of the Association for Environment Conscious Building. And a number of my projects have gone forwards to win awards and been shortlisted for awards in recent years. And I've also had the opportunity to design some of the world's kind of lowest energy homes in terms of them satisfying the world's leading quality assurance standard, which is the Passive House standard. Now, I've also had the great opportunity to contribute to a book that was authored by or edited by Sunan Prasad, who's ex-chair of the RIBA. That was Retrofit for Purpose, where we were looking at non-domestic buildings. And then there's also domestic properties. Some projects that I've worked on were featured in the Residential Retrofit book by Marion Bailey. So that's enough about me. Oh yes, and I had the opportunity to go down to New Zealand earlier this year to help launch the South Pacific Passive House Conference. So, and a little bit more just to set the scene. Some testimonials from some people that I've worked with and that I know quite closely. So there's Alan Thompson here from Gen 2 Construction. After having worked with him on the Racecourse Passive House scheme, he had these kind words to say, saying that my technical knowledge of low carbon and building performance design is breathtaking, which is I always find a bit of a humbling thing for him to have said, but yeah, that's quite surprising, and it's very flattering. And then also Wolfgang Feist, who was the co-creator of the Passive House Standard and the creator of the Passive House Institute, has identified me as being one of the pioneers to introduce Passive House to the UK. And he's observed that my ongoing research into building performance makes me one of the most skilled and knowledgeable Passive House architects. So that just gives you a context, not for reasons of boasting, but just because this is going on the internet and you won't necessarily know me from Adam. So I'd just like you to have a bit more confidence that what you're hearing is trustworthy. Now, getting into a bit more detail, what we see is part L of the building regulations, and this is really focused on energy efficiency and carbon emissions from buildings. And there are two particular bits that I'd like to draw your attention to. And it's the green boxes that are in the building regulations. Now, each volume of the building regs is a reasonably chunky document in its own respect, shall we say, and a lot of it is guidance notes. It's not actually legislation. The green boxes are the legislation. And this is where it's really important to kind of look closely at what's being said. And in both section 26 and 26A, you'll see that it reads, where a building is erected, it shall not exceed the target. Now, and then whether it refers to carbon emissions or the fabric energy efficiency rate. And it's really quite clear there. Shall not is not an ambiguous term. It's very specific. So what's been going on over recent years, over the last 10 or 15 years, is that Leeds Beckett University have been measuring the heat loss from houses. And they've been doing this without the intervention of people living in homes. This is a more empirical way of really determining how well buildings or houses have been designed and constructed. And they do this using a technique known as a co-heating test. Now, I'm not going to go into all the finer details about how that test is actually undertaken at the moment. It's suffice to say that it's perhaps a parallel to a car coming off the production line, then going into a test lab so that they can determine how efficient the energy, the engine is and what the emissions are, assuming that there's no cheating software going on. And the great thing about this approach is that it's actually taking measurements and establishing clear criteria for performance. And it's important to recognise that at the moment, there aren't these kind of measurements being taken in the housing industry at all. So therefore, it's basically only superficially regulated through the building regulations as it currently stands, because there's no verification process that's as rigorous as a co-heating test. Also, Leeds Beckett University have also been taking measurements of airflows in properties, and there's some really important revelations coming out of that. So let's move forwards and have a little look at some of the data that they've produced so far. In this graph, what you'll see is a vertical axis, which is the carbon emissions rate, and along the bottom axis, going from left to right, you'll see various different design standards. On the far left, you'll see Part L 1995 all the way through to what was going to be Code to Level 6 for 2016. You can see a blue dots with some blue lines joining them together. Now what those blue dots are showing you the designed performance. So if we have a look at example detailed, which is in blue on the bottom axis, and we track up, we can see a blue dot. Now that blue dot tells you how it should have performed in theory and in reality. The measurement, however, is the magenta square, the as-built. And you can see that there's a gap between the theoretical performance and the actual performance. And if we then track over left, what we see is that the example detailed, though it should have been performing closer to, somewhere beyond Code Level 4 2013, it was actually performing much more close to Code Level 3 of 2010. Now, it's important to recognise this because when we start to look at this graph, what we start to recognise is that we've got the blue, which is the predicted performance, and the red, which is the measured performance. And what you can see is in every single case that the measured performance is greater than the predicted performance, and often it's by quite considerable margins, often around about 30 to 60% more than was expected. That is until we get over onto the right hand side of the graph now, because what you see is some bungalows that have been constructed in Hawkley-Spring, and these are doing something remarkably different, because the difference between the theoretical performance and the real performance is actually within measurement error of the co-heating test. So whilst there is a slight difference, it's within acceptable boundaries. Furthermore, because they're designed to the Passive House standard, they are designed to use a lot less energy than any of the other houses in the study. But I would warrant that you could still have a building that's going to be designed to achieve the building regulations, so it would have higher energy use, but you could still close that performance gap if you know how to do it properly. And this is the really crucial thing. Because what you can see is that 95% of the dwellings that have been studied aren't actually performing the way that you'd expect. And therefore, if you're a consumer and you buy a house, even a new house, and it hasn't been constructed and designed properly, then you're effectively being missold because you're purchasing faulty goods. And I think that this is a really, really important and imperative issue that people need to recognise, because designers and building contractors are designing and building goods that aren't necessarily fit for purpose. Then you have people selling properties that are fit for purpose, and they're being bought by consumers. So there's some major issues. Now, these performance gaps can be closed, and the Racecourse Estate, which are the bungalows on the right-hand side, it's a project that I had the opportunity to design and oversee the construction of. And that really shows that these issues can be addressed, and it's not some major challenge that it's as though it's a theoretical challenge and we can never really close this gap. It absolutely can be closed. So therefore, consumer rights can be protected in the appropriate way. And the same kind of thing starts to arise with non-domestic buildings as well, because if we start to have a look at the box, the red box that's just appeared, within there is the Passive House Standard and the Riedberg School, which is based out in Germany. And we also have a number of other schools that have been constructed under the Building Schools for the Future programme. Now, you can see what their emissions are using the graph of the horizontal axes. Now, the target was that they should have achieved 27 kilograms per metre square per annum. And you can see that that's not been achieved. Now, the key thing to recognise here is that this is occupied data. And I don't really think that designers have got a huge amount of control over how buildings can be occupied. We can make certain informed decisions that are basically guesstimates that can be developed with clients, but we can't really legislate behaviour. So why I really like the coheating test is because it's irrespective of how buildings are being used and occupied. It's a really clear clarification about how the buildings are being designed and then constructed, so that they are then ready for use by an occupant, by a consumer. So that's plenty about energy, and I think the key thing to recognise with energy is that because the houses are needing more energy to be heated, that means your fuel bills are going to be higher. And if your fuel bills are higher, then your carbon emissions are higher. And if your carbon emissions are higher, then you don't just pay more on your fuel for the fuel itself, but you also pay higher taxes or more taxes to cover the costs, to cover the emissions that are coming from those fuels. So there's some major issues cropping up there. Now, if we start to turn our attention to indoor air quality, then we're really thinking about ventilation and the way that houses have been designed. And it's key to recognise that there are ways of houses being polluted from external sources and also from internal sources. Now, I'm not going to go into the finer details of those particular contaminants and what impacts they have in any major respect. The key thing is to recognise that these issues arise, and that what's been found is that houses are not performing the way that they're expected to. For instance, in the building regulations, there are 4 strategies for ventilation. There's systems 1 and 2, which basically use a technique called trickle vents, and then have either mechanical extract ventilation or passive stacked ventilation in the kitchens and bathrooms. Now, what's the studies, so you'll recognise these by the little ventilation slots above the windows, the gaps around the windows. Now, what's been found is that people tend to close these trickle vents because of cold drafts on the back of their neck, perhaps, or because of acoustic issues. And this means that the indoor air quality that people are expecting gets kind of disrupted by their behaviour, because they're placing other things as higher priority, because we don't have a sensory organ for indoor air quality. So there's some major issues there. But then if we go one stage further, then there's actually research by Sterling Howison from 2014, and he identified that in an airtight house with trickle vents, the house is likely to result in a more toxic and hazardous indoor environment with concurrent and significant long-term and insidious impacts upon public health. Now, that's kind of there's a lot in that to unpack, really, but suffice to say, he's really raising some major concerns that the actual building regulations themselves are not fit for purpose, because what he describes is, he says that the methodology underpinning current regulations cannot be considered creditable, and that's because the ventilation slots are not sized appropriately. Now, if we go a few steps further, then studies have also shown that where we've got the mechanical fans in these naturally ventilated houses, the houses with trickle vents, then what we find is that in the majority of cases, the fans are actually switched off. And the reason for that, as we understand it, is because of noise issues or because of people perceiving that they're using additional electrical energy, and that's something that people might not want, rather than them appreciating that the reason the fans are there is to remove excess humidity and therefore prevent other risks arising. So what kind of risks are we talking about? Well, if a building isn't properly ventilated, then what you can get is higher dust mite populations, because dust mites enjoy a more humid environment, and therefore the feces from dust mites which you can find in pillows, in beds, in sofas, and in carpets and the likes, they all help to support a higher incidence of asthma occurring in homes. And I think that that's a really key or major issue that needs to be addressed, because the UK has got one of the highest asthma rates in the world. So we've got to really think about getting the ventilation done properly in our houses. Also, when you've got higher levels of humidity, you've got greater risk of mold growth. And again, that can cause all sorts of impact upon the health and well-being of you and your family. So making sure the ventilation is addressed properly is really key. Unrectified, these problems could be an issue for every owner of the house until the house is demolished, both for energy performance and for ventilation. Now, if we go one step further and then start to think about mechanically ventilated buildings, then what we find is that, well, there's a study that's been done by an industry organisation called BizRIA, and they've found that 40% of properties so they studied 40 properties, I apologise, and 95% of all those houses that were evaluated failed to meet the requirements of the building regulations, and in some cases they had numerous modes of failure, which means there were various different issues arising. So some really key issues coming up there in terms of mechanical ventilation and natural ventilation strategies don't appear to be working in the building regulations sense of things. Another study that's been undertaken looked at mechanical ventilation. It looked at 54 dwellings across 46 different sites. And it was found that only, there's a typo in here, it should say 90% rather than 80%. It was found that about 90% only had a design for the ventilation system, which alarmingly means that 10% didn't even have a design. Of the total dwellings assessed, what they found was that 72% of designs didn't actually comply with the building regulations. So before you've even got out the starting gates, there's problems existing with the designs actually achieving Part F. And then in practice, what was found was that only 19% of the buildings as constructed were meeting the regulations. Meanwhile, the 81% were failing or borderline conditions. So therefore, there's a major issue there, where almost only 1/5 of properties, 1/5 of houses are actually satisfying the performance requirements. But this only accounts for 61% of the study. A number of other dwellings were also studied, and these were designed to a different quality assurance standard and system. They're actually designed to the Passive House standard, the world's leading quality assurance standard for low energy buildings. And what was found was that 85% of these dwellings were actually performing as required. They were meeting the regulations, the Part F of the building regulations and the Passive House requirements, and only in 15% of the time were they either failure or borderline conditions. Now, there's still room for improvement, of course, but we're getting much closer to the right kind of answer in this kind of scenario. And that's, as I say, 39% of the study. So it's quite a significant quantity. Now, it's not just a case of ventilation though, because noise issues are also a key criteria, and this is something that the building regulations don't actually have a requirement for mechanically ventilated houses. What they have is a recommendation, and the recommendation is that the noise level should be 30 dBA, and basically what the research shows is that around about 30% of people will be dissatisfied with the noise levels that are coming from the mechanical ventilation systems. Now, Jack Harvey Clark, an acoustician that I know that I've worked with, we reviewed 1,000 homes and we found that there were persistent complaints throughout the world about noise levels from mechanically ventilated houses. But there was very, very little information about what the appropriate noise levels should actually be. We did find some information in Finland, and we also found more recently this cost action survey study that's been done to help inform new developments in the European standards. What we should target from a good engineering point of view is at least 90% satisfaction, ideally 95% satisfaction. So that means that noise levels should be somewhat less than 24 dBA. Now, what this means is that we've got to think about the conditions under which this should be occurring as well. The research in Finland suggested that bedrooms should be the quiet room, and it should be where the mechanical ventilation system is on boost setting, because what we don't want to be doing is disturbing people's sleep at night and therefore disrupting that can have an impact upon their well-being. And if they are getting disturbed nights of sleep because of noisy mechanical ventilation, then what happens is they switch the mechanical system down or off, which obviously impacts upon the indoor air quality and means that the mold growth and dust mite populations can proliferate, and that can have a negative impact upon health and well-being. So as I say, what's also been found is the positioning of mechanical ventilation units has been particularly flawed, and it's causing some major issues. So we've really got to pay some close attention to this. Which is why when Jack came along and did some tests at the Racecourse Estate in Horton this spring, the passive houses that I contributed to, then what was found was that the noise levels meant that around less than 10% of people would have been dissatisfied. So around about 90% or more of people would have been content with the noise from the mechanical system. Where the noise levels were exceeded, it wasn't because of failures in the design. It was actually because people have brought in ticking clocks, or there's fridges buzzing, or in one case there was even grass being cut outside when the measurements were being taken, and that actually muddied the sound. But it's important to recognise that it wasn't actually the failure in the design process. It was that people have made a decision to compromise the noise or introduce this aspect of background noise, and that's their decision. You can turn your clock off, you can replace it, you can get a quieter fridge. All these things are under your control, but it's very difficult for you to make adjustments to the noise coming from a ventilation system after it's been constructed. So, key thing to recognise is the RIBA plan of work, and let's think about how we can avoid these problems occurring. Now, I'm not going to go through this in too much detail, but basically we've got various different stages from the RIBA plan of work, going from the strategic definition all the way through to in use. And there are different milestones that we have along the way. Now, the opportunities that we have can be represented on this vertical axis for high and low. And basically what we have is a design process, traditional design process. We start off with a low level of effort, and the effort really then picks up once we get into a more detailed design phase, or we start to look at the technical design, and then it starts to trail off throughout the construction process all the way through to handover. Now, it's important to recognise when we have the opportunity to make changes, and what we find is that really the chance to make changes to the building in order to set the right wheels in motion are at the initial stages of a project, right at that early stage, and then they very quickly trail off as the concept design starts to become fixed, or the design moves into the more detailed developed stage just prior to planning applications being made, and then it's even more firmed up when you get into the technical design stage. So it becomes increasingly difficult to make changes because you get various different decisions and lock-ins from different players. You've also got the issue whereby it becomes more and more costly to make changes. Now, as you start to develop more and more technical information, more and more documentation that describes and defines the design of the building through drawings, specifications, schedules, etc., then the cost of making changes and going back and making revisions becomes more and more onerous. But once you get on site, that's when it really starts to become a major issue, because making these late stage design changes is a really, really worrying problem. Now, what tends to happen is that all of this, because of the way that the traditional design process works, you produce all this information and then you get it costed by going out to tender, and that's this red dot. And at that particular juncture, that's when you find that the project goes over budget, and you then have to start thinking about not so much value engineering, in all honesty, it's more a cost-cutting exercise, trying to bring things into budget. It's not looking for the optimum solutions anymore. So if you really want to value engineer a project, you start at the earliest possible stages, and then you might start to try and get the right kind of resolution at these later stages if you've been using a traditional design process. But the best thing to do is to prepare. So in the words of Abraham Lincoln, if you had 9 hours to chop down a tree, I'd spend the first 6 sharpening my axe. It's really, preparation is key. So if we start to question the traditional design process, what we want to be doing is making changes early on, not at the later stages, and certainly not once we're on site. So therefore, we're looking for a more integrated design process, something that actually brings things together in a much more concerted fashion from the conceptual design stage. And that's what I heard. That's what you get with a passive house design when it's been implemented properly. So mistakes can be overcome if they're tackled before they're made. So this is all about anticipation and thinking about things in the most appropriate way. One of the things that I do, in addition to designing things through my architectural practice, I also work with other architects and do design reviews, and I deconstruct their buildings before they've been built. So we look for details that could cause issues and complexity that could put them off their course. So this works particularly well for passive house or ACB silver homes, and basically going through, redlining the drawings, identifying construction details that could be a challenge, and then starting to identify construction technologies that can start to deliver the appropriate performance, looking at construction details, how they can be rectified so that they can deliver the performance that's required as well. And therefore, we can start to deliver buildings that perform as predicted. And obviously that means that when the properties are sold, then the Consumer Rights Act is observed. Now, a lot of designers tend to push a lot of the work onto the building contractor, suggesting that it's actually a construction issue, but in my experience, the evidence suggests otherwise. So therefore, really getting to grips with the construction program and thinking about how the contractor is going to build out the houses as well is really key. It's not just a case of looking at the construction details and making a few comments on that. And then also doing site evaluations, making sure that the systems and components have been assembled correctly and ensuring that the quality of work is appropriate. I also have a traffic lighting system which enables coordination throughout the design team and makes life a lot easier for both the design teams and the contractors. So as a responsible developer or contractor, or perhaps a self-builder, if you think that you could benefit from a Better Building Blueprint cost construction review, or if you would like me to contribute to your design from an initial stage so that you can get a building that's going to perform as predicted, or have greater confidence of that at least, then feel free to get in touch. I think that the way that you can do that is to contact me, Mark Siddall, at my email address, which is mark@leap4.it. That's mark@leap4.it. Or you can phone me on 0191 375 7702, or on my mobile, which is 07795 031700. And I think that I think this starts to give you a much clearer clue as to how things can move forwards. So thank you very much for your time. I hope that you found this an informative presentation and that you've got a much clearer understanding now about how you can start to take pragmatic steps towards addressing the performance gap, and you've got greater awareness of what that gap is and how it could affect consumers if you're designing, if you're constructing or selling houses to a consumer, or indeed if you're a consumer and you're thinking about buying a house. Okay, thank you very much, and thank you for your time.